Very good morning to all of you. We will wait 2-3 more minutes for others to join, then we'll start. So once again, a very good morning. I welcome you all in this lecture. So let me first give me my introduction. My name is Navdeep Pandey and I am currently working as an assistant professor in Darbhanga College of Engineering, Darbhanga. and I am going to teach you the thermodynamics subject for your gate training. Then before going into the subject, let me tell you what is the weightage of the subject thermodynamics in the gate examination. The weightage varies from year to year, and it also varies with respect to the morning shift or afternoon shift of the examination. But overall, if you see the weightage, it varies from 7 to 16 marks. Means it can go up to it can be as low as 7 or 6 marks, and it can go up high as 16 marks. In 2011 paper, thermodynamics would consist of 16 marks. Okay, and all these marks are very scoring. If you have gone through all the basic concept of thermodynamics, you will be very it will be very easy to score the marks, because the syllabus is not that much big, or it is very compact as compared to other subjects where the syllabus is very vast. Okay, so what we'll do in this class, we will start from the very basic, then we'll move, or then we build our concept so that we can solve all the questions related to the competitive exam, not only the gate and other competitive exam also. Okay, so in class also I will be solving some numerical problems, or problems related to the gate, previous year gate questions, ESE questions, and others. Okay? If you have any query during the class, during the class, then you can put it into comment. I will check and I will reply. One more request I will do. I have shared you the Telegram channel link. Please join that channel, because it will be very easy to communicate with you if any problem is there. Like you are facing any problem with any question, you can directly post that question in there, in that channel, and as per my free time, I will be posting the answer of that question. Okay, so let us move forward. So when we talk about thermodynamics, what are the different, अगर मैं आपसे बोलूं कि जब मैं आपको thermodynamics word बोल रहा हूं, so what are the different words which are coming into your minds? ठीक है, so first word will maybe is heat, because you are saying that thermo is related to the heat. Other can be energy, and energy can be different types. Then if you are talking about energy, then there can be a question, what are the different types of energy? And energy, when you are talking about energy, then you know the basic principle of energy, that is conservation of energy. And all these three concepts leads to the another concept, that is energy transformation. Okay. So basically, in thermodynamics, we will be dealing with heat, then which is also a form of energy, different types of energy, conservation of energy principle. Then on the basis of all these three concepts, we will be dealing with the devices which are used for energy transformation. For example, when we talk about energy transformation, we have systems that deals with energy transformation. Systems that transforms energy. For example, you all know power plant, IC engine, fuel cells, rocket engines, etc. Okay, so you can see there is a vast application of thermodynamics in our day-to-day life. Okay, now what will be the way of teaching in this subject? That I will be putting or raising some questions with the help of question words. These three question words: why, how, and what. Continuously throughout the subject, I will be raising the questions, and with the help of questions, I will be explaining the concept. The first concept, जब आप thermodynamics subject पढ़ने जा रहे हैं, when you are going to study thermodynamics, so very first question comes out: why? What is the need of thermodynamics? Why, being an engineer or a mechanical engineer, why you need to study the thermodynamics? Then, what this subject consists of? What are the different areas which thermodynamics consists? Yeah, recording is will be saved and will be shared on YouTube channel itself. So don't worry about that. All the classes will be taken on YouTube Live itself. No Microsoft Team will be used. Okay. So again, this word is the combination of two words. You all would have known that. That is therme plus dynamics. The word therm means heat, and word dynamics means motion. Dynamics doesn't mean only motion. It means motion in which we are considering the forces also. Okay. So basically, we can say that thermodynamics is the science of flow of heat. We can say that it is the science of flow of heat. The basic origin of the third subject thermodynamics was how to extract or how to convert heat energy into mechanical energy. Basic origin of thermodynamics was based on how to convert heat energy into mechanical energy. And it's not only how to convert, it is converting efficiently, because the first heat engines which came or steam engine came into 1750s, but the work subject thermodynamics it came into originated around 1800 centuries. Okay, so you can see that well before the thermodynamic subject was existing, we have developed the engine or heat engine, we can say. But that the heat engine which we developed before the origination, before the invention of that subject thermodynamics, they were very inefficient. These engines were very inefficient. Okay, so there was a need that how to increase the efficiency of these engines. So because of this need, the subject came into picture, thermodynamics. So initially, when it was originated, the thermodynamics was mainly concerned towards the heat engines. How we can convert heat energy into mechanical energy, what the main concern. But as the subjects now evolved continuously with time, now almost all the aspects of daily life concerned to the thermodynamics. For example, human body, it works on the principle of thermodynamics. We consume some heat, consume some energy, we do some work, some part of energy stores inside our body. Our vehicles, automobiles, power plants, our refrigerator, air conditioning. There are number of examples which concern to the subject thermodynamics. So, in present condition, the area or scope of the thermodynamics is very large. Okay, that's why it is necessary to read the thermodynamic subject or to have the awareness of basic principle of this subject. So thermodynamics it deals with systems in equilibrium. That means if it deals between two equilibrium state, if system is moving from one equilibrium state to another, one to two. For example, let us say we have a cup of coffee and the temperature of coffee is, let us say it is 20 or 50 degrees Celsius. And if you leave this coffee into the environment and if the environment temperature is 25 degrees Celsius. So initially when the temperature was throughout the temperature was 50 degrees Celsius. So this one was the first equilibrium state of this system. If I am considering my coffee as my system, if I am considering this coffee as my system, then initially when throughout the system the temperature was 50 degrees Celsius, it was my initial equilibrium state. And when you leave this coffee into the atmosphere freely, the temperature will go to 25 degree Celsius, or my system will attain the temperature which is equal to 25 degrees Celsius. So it will attain an equilibrium state which is different from its initial equilibrium state. So system, we can say in other words that system is changing its equilibrium state from one state to another state. And we will concern only these states. So that's why I have written deals with systems in equilibrium. That's the main important. Then subject developed well before when we have the knowledge of molecules or atoms. So the thermodynamic subject mainly deals with the macroscopic properties of matter. What I say, I will again repeat. I told that subject developed before people knew about atoms and molecules. So it is based on macroscopic properties. Macroscopic properties of matter. Okay, because the subject was originated well before the we have the knowledge of molecules and atom. So that's the reason it is basically mainly related to the macroscopic properties of matter. We don't go at the molecular level. In subsequent times, when the knowledge of atoms and molecules originated, then it also developed with respect to microscopic approach. What is the macroscopic and microscopic? That we will deal in subsequent lecture. So don't worry about that. We will discuss these things in the okay. Just Navneet, both microscopic and macroscopic studies are there. I am not saying in this sentence I have nowhere written that microscopic studies are not there in thermodynamics. I am saying it subject was developed well before we knew the atoms and molecules about the atoms and molecules. That's why it was initially developed which was based on the microscopic properties of matters. I am not saying it is not study that microscopic properties we are not studying. जैसे जैसे सब्जेक्ट डेवलप हुआ, जैसे जैसे हम लोगों के पास इंफॉर्मेशन आई अबाउट माइक्रोस्कोपिक नेचर ऑफ द पार्टिकल ऑफ एटम्स, थर्मोडायनेमिक्स उस एरिया में भी डेवलप. ठीक है. No, you are not wrong. Then next is all the laws of the thermodynamics are entirely empirical. What do you mean by entirely empirical? Empirical means it is based on experiments. That means all the laws has been derived from the nature. We did experiments and we find out different laws with the help of experiment, and with the help of a tool which is called mathematics, we expressed these laws in some form of equations. Okay, so again what I told, all the laws of thermodynamics from zeroth law to third law of the thermodynamics, all the laws are entirely empirical in nature. Empirical means all the laws are based on experiments and derived from the nature. With the help of experiment we establish law, and by applying mathematics as a tool we establish some equation that we call equations of first law, second law, etc. Okay, and these laws can be summarized in four, or these experiments can be summarized in four laws. These observations can be summarized in four laws. You all know what are the different four laws. First one is zeroth law, and before that, and each law or every law defines a quantity and a concept. All the four laws defines a particular quantity and a concept related to that quantity. For example, when we talk about zeroth law defines a quantity that is called temperature. And the concept which defines related to this temperature is temperature measurement. That is all about zeroth law. In other words, you can say it is a common sense law. Why I am saying it is common sense law, you all know. Second is first law of thermodynamics. The quantity which this law defines is energy. And the concept related to the energy which defined is energy conservation. On In other words, you can say, like here, I can say common sense law. According to the first law, it says you can break even law. This all with the sentence which I am writing in bracket, it's informal way of representing the law. Okay, I will explain each and everything. Just give me, let me complete all the laws, then I will explain. Then third one is second law, and the quantity which it defines is entropy, and the concept related to that is in which way process will go. Or in other words, we can say what is the direction of time. किस डायरेक्शन में टाइम प्रोसीड करेगा, that tells the second law. ठीक. Then we can say in other words, you can break even at 0 Kelvin. Then last one is third law of thermodynamics. Third law of thermodynamics gives a numerical value to, or defines a numerical value to entropy. And it says you can't get to 0 Kelvin, even if you have infinite amount of resources. So what does it mean? वॉट एवर आई एम राइटिंग, इसका मतलब क्या है? ठीक है, सो फर्स्ट जब मैं बात कर रहा हूँ जीरोथ लॉ की, सो जीरोथ लॉ यू ऑल नो इट डिस्क्राइब्स द टेम्परेचर, टेम्परेचर को डिस्क्राइब कर रहा है। और बेसिक लॉ क्या है कि इफ टू बॉडीज आर इन थर्मल इक्विलिब्रियम विद एनी थर्ड बॉडीज, देन these two will also be in thermal equilibrium. That's why it is we are calling it common sense law. ठीक है, कि कॉमन सेंस है, अगर दो बॉडीज आपस में थर्मल इक्विलिब्रियम में है, if these two are in thermal equilibrium and these two also are thermal equilibrium, then these two body will be in thermal equilibrium. This is a common sense law. That's why we are calling it a common sense law. Second one is first law, which tells about energy and energy conservation. First law tells us that we can convert heat into work. It does not tells about that I cannot convert total heat into total work. ये ऐसी कोई बात नहीं बोलता है। फर्स्ट लॉ हमसे बोल रहा है that we can convert total heat into total work. That's it. That's why I am saying that you can break even law. Break even का मतलब क्या होता है? आप लोगों ने इंडस्ट्रियल इंजीनियरिंग वगैरह में पढ़ा होगा। ब्रेक इवन मीन्स द पॉइंट व्हेन यू डोंट हैव नो प्रॉफिट नो लॉस। ओके, नो प्रॉफिट नो लॉस का मतलब क्या हुआ यहाँ पर कि वॉट एवर हीट एनर्जी आई एम प्रोवाइडिंग, आई एम गेटिंग द वर्क आउटपुट. It is coming from what? First law of thermodynamics. Okay. Then again, when you move towards the second law, it is describing the entropy. The second law tells that you can break even, but only at 0 degree Kelvin. फर्स्ट लॉ ने मेरे पे कोई ऐसी कंडीशन नहीं लगाई. फर्स्ट लॉ इज टेलिंग कि आप वर्क हीट को फुली वर्क में कन्वर्ट कर सकते हैं. बट व्हेन वी आर मूविंग टुवर्ड्स द सेकंड लॉ, इट इज सेइंग you can convert or you can break even only at 0 degree Kelvin. अगर आप 0 degree Kelvin को अचीव कर ले रहे हो, then you can break even. Okay? अगेन ब्रेक इवन का मतलब वही है, नो प्रॉफिट नो लॉस. यहाँ पर अगर पूरी की टोटल हीट वट एवर हीट यू आर सप्लाइंग इज कन्वर्टिंग इनटू वर्क, सो यू आर नॉट गेटिंग एनी प्रॉफिट और नॉट हैविंग एनी लॉस. प्रॉफिट कब होता? जब आप कम हीट सप्लाई कर रहे होते हो, वर्क आपको ज्यादा मिल रहा होता, दैट विल बी वुड हैव बीन अ प्रॉफिट. लॉस कब होता है? जब आप हीट सप्लाई कर रहे होते और वर्क कम मिल रहा होता, तो वर्क आउटपुट विल बी लेस देन द हीट, तो वो लॉस होता. ब्रेक इवन मीन्स दोनों इक्वल हैं. ओके, तो सेकेंड लॉ इज सेइंग यू कैन ब्रेक इवन मीन्स यू कैन फुली कन्वर्ट योर हीट इनटू वर्क बट एट 0 डिग्री केल्विन. ओके, सो स्टिल यू हैव द होप कि अगर आपके पास 0 डिग्री सेल्सियस केल्विन आप अचीव कर लो, देन यू कैन फुली कन्वर्ट योर हीट इनटू वर्क. ओके, देन कम्स द थर्ड लॉ व्हिच इज द मोस्ट डिप्रेसिंग लॉ. व्हाई? अभी तक जितनी भी होप्स आपकी फर्स्ट लॉ और सेकंड लॉ ने आपकी होप्स जो जनरेट करी कि आप फुली कन्वर्ट कर सकते हो और यू कैन अचीव ब्रेक इवन, थर्ड लॉ ने बोल दिया यू कांट गेट टू द 0 डिग्री तो 0 केल्विन. आप 0 केल्विन को अचीव कर ही नहीं सकते इवन इफ यू हैव इनफाइनाइट अमाउंट ऑफ रिसोर्सेस. ओके, सो इट इज बेसिकली डिसीटिंग. ओके, पहले फर्स्ट लॉ is saying that you can convert heat into work. Second law is saying you can convert but only at 0 degree Kelvin. And third law is saying that you cannot achieve 0 degree Kelvin. So basically, as you move from first law to second law, and then you go to the third law, you will have a concept how you can convert heat into work. Okay. So this was the brief overview of all the laws. Now we will move from the first chapter, and in this chapter we will deal with some definitions. Okay. So first of all, we all know कि अगर हम लोगों को कोई भी किसी भी चीज की स्टडी करनी है, so we have to define our body. For example, in case of mechanics, अगर आप mechanics पढ़ रहे हैं and you want to do the analysis of the body which is under some forces, the first step जो आप लोग फॉलो करते हैं वो क्या करते हैं, उसका फ्री बॉडी डायग्राम बनाएंगे. ओके, यू ऑल एग्री कि अगर मैकेनिक्स में मुझे कोई प्रॉब्लम सॉल्व करनी है, सो द फर्स्ट स्टेप विच आई फॉलो विल बी द फ्री बॉडी डायग्राम. मुझे सबसे पहले उसका फ्री बॉडी डायग्राम बनाना है, वहां पे देखना है उस बॉडी पे व्हाट आर द डिफरेंट फोर्सेस विच आर एक्टिंग ऑन दैट बॉडी. सिमिलरली व्हेन वी टॉक अबाउट द थर्मोडायनेमिक्स, we define our system. If we want to study any device or anything, we have to define our system. Until and unless we are not able to define our system, system का मतलब क्या है? Whatever we are studying, मेरा main focus area क्या है? If I am not able to define that consciously, then I will not be able to do any analysis related to that system. Okay. So system is the part of universe under study. There are number of definitions you will get in different books. Okay. In other words, you can also say system is a fixed mass or region in space under study or under consideration. Okay, it is a fixed mass or region. I am saying or, that means either fixed mass or fixed region. Okay, I cannot define system only on the basis of mass or only basis of the region. Why? That we will see in a while. Okay, in space under consideration, space में जो भी fixed mass और fixed region को मैंने consideration में लिया है for study, that is called our system. Okay, then comes the surrounding. Surrounding is everything except system. Everything except system is surrounding. Okay, and the surface which is separating system and surrounding is called boundary. Okay, so basically we discussed three things. First one is system, what is a system. Second is what is surrounding, and what is a boundary. Okay, system is any fixed region or space which we have taken into consideration for study. Surrounding is whatever is remaining in the universe except the system is called surrounding. Then the boundary is the separating surface between the surface which is separating system and surrounding. Okay. Ratish Kumar, I am not writing any definitions. I am just putting some bullet points. Okay. अगर ये भी points मैं नहीं लिखा रहा हूँ, अभी आपको सही है कि आपको सिस्टम यू हैव रीड tons of times. That's why you are saying that don't write these things. तो जैसे हम लोग आगे बढ़ेंगे, अगर if I am not writing a bullet points, तो ये जो आपके दिमाग में है वो हमेशा के लिए रहने वाला नहीं है. सिस्टम और सराउंडिंग के लिए आप इसलिए बोल रहे हैं बिकॉज यू हैव रीड what is system, what is surrounding number of times, and I am not writing any definition. I am just writing a bullet points. Okay. Then boundary can be different types. It can be movable or fixed, and it can be real and imaginary. Surrounding, बेटा everything except the system is surrounding. अगर मैं इस फिक्स्ड रीजन को अपना सिस्टम मान रहा हूं, तो whatever everything else except this system is surrounding. For example, अगर let us say कि कोई classroom is my system. This is a classroom. Inside this classroom, some students are sitting, and I am considering this classroom as my system. So everything beyond this classroom is my system. Yeah, whole universe except surrounding me, except its system is my system. Sorry, surrounding. Okay, this is my system, and everything this except this system is my surrounding. Okay, one term comes like immediate surrounding. So if I am talking about, if this is a classroom and I am talking about what will be the immediate surrounding of this classroom, you can say the immediate surrounding of this classroom is your college area. Okay, so immediate surrounding means what is the surrounding entities which are just nearby to that system, which is called immediate surrounding. Okay, so basically when we talk about system, there are mainly three type of system, you all know. First one is open system, which is also called control volume. Second one is closed system, which is also called control mass. And third one is isolated system. Okay, so open system, exchange of mass is allowed. Let us say mass and energy also. When we talk about closed system, exchange of mass is not allowed. Okay, and in case of isolated system, both mass plus energy exchange is not allowed. Okay, so when we talk about exchange of mass is not allowed, that means mass inside the system is remaining constant. Mass is not changing for a closed system. Okay, so can we say that for a closed system mass is constant? Tell me, can we say it? Is this sentence is correct or not? If I am saying that for a closed system mass is constant, whether this statement is correct or not? Okay, let me give an example. Let us say this is a PBR. Okay, this side is a screen side. अभी सारे PBR खुल भी गए हैं, so you can relate. This is your entrance gate and this is your exit. Okay, I am considering this whole hall as my system. Okay, then there will be number of people which will be sitting inside the system. The PBR hai, so obviously some people will be there. Okay, let us say a particular time some people are there inside that hall or PBR. Okay, now let us say that the people which are inside is 10 or sorry 50. 50 people are inside this PBR. Okay, now what happens? Two new persons enters into this PBR. Okay, and some two persons which are sitting inside the PVR, they so thought that movie is boring, so they leave the through the exit. आ रहा समझ में मैंने क्या बोला? मैंने बोला कि कुछ आफ्टर सम टाइम दो नए बंदे एंटर करते हैं और दो जो पुराने बंदे जो यहाँ पे ऑलरेडी बैठे हुए थे वो एग्जिट से लीव कर जाते हैं बिकॉज मूवी इज बोरिंग. दे थॉट दैट मूवी इज वेरी बोरिंग, सो दे लेफ्ट द हॉल. ओके, सो नाउ फिर से दो पर्सन अंदर आए और दो पर्सन बाहर चले गए, तो नाउ अगेन द नेट नंबर ऑफ पर्सन इज अगेन 50. So if I am saying the total mass of the system, then mass of the system was 50, and here also mass of the system is 50. Even though the mass is crossing the boundary of this system, mass remains constant. आ रहा है समझ में क्या बोल रहा हूँ? Even though mass is crossing the boundary of the system, अगर मैं आपसे पूछूं कि whether it is mass exchange is taking place between system and surrounding or not, you will say yes sir, mass exchange is taking place between system and surrounding. But still there is a condition that mass is remaining constant. Okay, एवरी टाइम जैसे दो बंदे अंदर आए, दो बंदे बाहर चले गए, फिर दो बंदे अंदर आ रहे हैं, दो बंदे बाहर चले गए, या एक अंदर आया एक बाहर चला गया, अगर इस कंडीशन को फॉलो कर रहे हैं तो इस कंडीशन में मास कांस्टेंट रहेगा इनसाइड द सिस्टम ऑलवेज. मास तो कांस्टेंट है, बट आई कैन नॉट से दैट दिस सिस्टम इज क्लोज सिस्टम. Okay, for saying a system to be a closed system, both mass, so both quantity and identity of mass should be constant. Okay, मतलब क्या हुआ क्वांटिटी और आइडेंटिटी का? आइडेंटिटी मीन्स whatever mass was initially inside this system, that same mass should be at the last, till the last. आ रहा है समझ में क्या हो रहा? जो सिस्टम के अंदर मास है वो चेंज नहीं होना चाहिए. यहाँ पर क्या होगा कि जैसे ही दो नए बंदों ने एंटर किया और दो पुराने बंदों ने एग्जिट करा, यहाँ पर जो नए बंदे आए थे दे विल नॉट बी हैविंग व्हाट any idea whatever happened till now in the movie, so that their because their identity is new. आ रहा है समझ में क्या बोल रहा हूँ? Because their identity is new, they don't have any idea whatever happened inside the system before their entry. Okay, so since the mass is constant, quantity of mass is constant, but the identity of mass is not constant. So I cannot say that for a closed system only mass is constant. Never say that. For a closed system, quantity and identity of mass should be constant. Okay. Then, if you want to give example of the different system, then open system, you all know, almost 99% of the all the devices we use are closed system. IC engine, it is an example of closed system. Turbine is an example of closed system. Compressor, nozzle, diffuser. 99% of our devices, heat exchangers, they are open system. Sorry, I mistakenly I told previously closed system. Okay, these all are open system. Okay, and why we call open system as a control volume system? Because in case of open system, यहाँ पे हम क्या कंसिडर कर रहे हैं? This is an open system. This is an example of open system. Okay, because mass is continuously crossing the boundary. Okay, but what we have fixed the volume of this system. मैंने इस system का volume fix कर दिया है, मैंने इस system का region fix कर दिया है. I have taken a fixed region. Inside that fixed region, what are the interaction is taking place, I am going to study. So that's why I say that open system is control volume system. On the other hand, when we talk about closed system, I have fixed the mass of the system. मैंने मास को फिक्स कर दिया, मास की क्वांटिटी और आइडेंटिटी को फिक्स कर दिया. दैट्स व्हाई वी कॉल क्लोज सिस्टम एज कंट्रोल मास सिस्टम. ओके, ये जो टर्म है दोनों, दीज टर्म्स आर दैट मच पॉपुलर एज अगर आप कंट्रोल वॉल्यूम, व्हेन यू विल स्टडी द फ्लूइड मैकेनिक्स, इन केस ऑफ फ्लूइड मैकेनिक्स कंट्रोल वॉल्यूम डायरेक्टली डील्स, यू विल नॉट सी एनीवेयर दैट ओपन इट इज ओपन सिस्टम. Everywhere it will be written that it is a control volume. Okay, and for representing a closed system, it will be written only system. Keep that in mind. If somewhere you are finding it is written only system, then system means it is a closed system. And if it is written that control volume, then it means it is an open system. Okay, you will study these terms in your fluid mechanics. Thermodynamics, it will be clearly written that whether it is a closed system or open system. Then last, another one, isolated. Isolated example is, isolated system example is your thermoflask. And last, sorry, last is not, another is universe. Okay, why universe is an isolated system? Can anyone describe? How can I say that universe is my isolated system? See, what is happening. No exchange of energy is taking place. Yeah. Okay. Let us see. अगर मैंने लेट अस से एक रूम को जहां पर आप अभी बैठे हैं, दैट रूम आई हैव टेकन अ सिस्टम. ओके. तो आप किसके रिस्पेक्ट में, इफ दिस इज माय सिस्टम, देन एवरीथिंग एक्सेप्ट दिस सिस्टम इज सराउंडिंग. ओके. जो तुम्हें जो भी इंटरेक्शन, जो वॉट एवर इंटरेक्शन इज टेकिंग प्लेस, दैट इज विद रिस्पेक्ट टू सिस्टम एंड सराउंडिंग. Entropy of universe is constant. Don't go to the entropy. I know you have read all the thermodynamics, but just now we have started only the definition of system. So don't go towards the entropy right now. Okay, entropy में बहुत time है अभी. Okay, so जो भी interaction हो रहा है, whether it is a mass interaction or it is an energy interaction, that interaction is taking place between system and surrounding. Okay, for example अगर ये आपका रूम है, तो आपके रूम से बाहर जो भी, let us say another room is your surrounding. Okay, बाहर से जो भी कोई एंटर कर रहा है बाहर से आपके रूम के गेट के थ्रू, देन इट इज अ मास ट्रांसफर. ओके. इलेक्ट्रिसिटी आ रही है आपके रूम में या हीट आ रही है, देन दैट इज अ फॉर्म ऑफ एनर्जी ट्रांसफर. ओके. अब स्लोली स्लोली व्हाट आई एम डूइंग, आई एम इंक्रीजिंग माय सिस्टम. मैं एनलार्ज करते जा रहा हूं स्लोली स्लोली. ओके. एनलार्ज करने का मतलब क्या है कि मेरी बाउंड्री इंक्रीज करते जा रही है. अभी मेरा जो सिस्टम था, दैट वाज माय ओनली वन सिंगल रूम इन विच आई एम सिटिंग. Now I am enlarging. Now my system is my whole house in which I am sitting. Okay. So boundary, मैंने क्या करा, बाउंड्री को इंक्रीज कर दिया. ओके. अब हाउस जैसे ही मैंने इसको कंसीडर किया, तो सराउंडिंग क्या हुई, बाकी जो रिमेनिंग हाउस है मेरे हाउस के आसपास. ओके. देन आई हैव अगेन इंक्रीज द सराउंडिंग, लेट अस सिस्टम. लेट अस से नाउ सिस्टम इज माय सिटी. अब मैं पूरे अपने शहर को और विलेज को मैंने अपना सिस्टम कंसीडर कर लिया. ओके. तो अगर इफ सिटी और विलेज इज माय सिस्टम, देन सिटी और विलेज neighboring this my city is surrounding. Again you increase the area, now your state is your system. So whatever neighboring states are your surrounding. Now I have gone to country is my system. So as I am increasing the बाउंड्री ऑफ माई सिस्टम, मैं अपने सिस्टम को एनलार्ज करता जा रहा हूँ स्लोली स्लोली. ठीक है. तो देन आई विल कम टू अ पॉइंट वेयर होल यूनिवर्स इज माई सिस्टम. ओके. जब मैं बोल रहा हूं कि होल यूनिवर्स इज माई सिस्टम, देन देयर इज नथिंग remains for surrounding. Are you getting my point? When I am talking that whole universe is my system, that means except the system there is nothing, because I have considered my system like that कि whatever existing, that is my system. जो भी एग्जिस्ट कर रहा है उसको मैंने सिस्टम के अंदर इंक्लूड कर लिया है. सो एक्सेप्ट द सिस्टम देयर इज नथिंग. सो सराउंडिंग है ही नहीं. इफ द सराउंडिंग इज नॉट देयर, देयर इज नो पॉसिबिलिटी दैट सिस्टम और सराउंडिंग के बीच में कोई इंटरेक्शन हो. There cannot be any mass interaction, there cannot be any energy interaction if the surrounding is not there. अगर मास और एनर्जी इंटरेक्शन पॉसिबल ही नहीं है बिकॉज सराउंडिंग इज नॉट देयर, दैट्स व्हाई वी कॉल इट अ आइसोलेटेड सिस्टम. ओके. आई होप यू ऑल गेट द पॉइंट. कीप दैट इन माइंड. Whatever exchange whether it is a mass exchange or it is an energy exchange, you have to check on the boundary of the system. आपको सिस्टम की बाउंड्री पे चेक करना है वेदर देयर इज एनी मास एक्सचेंज और एनर्जी एक्सचेंज. सिस्टम के अंदर चेक नहीं करना है. कीप दैट इन माइंड. वॉट एवर एनर्जी इंटरेक्शन और मास इंटरेक्शन यू हैव टू फाइंड आउट, यू विल ऑलवेज चेक द बाउंड्री ऑफ द सिस्टम. ओके, सिस्टम के अंदर क्या आ रहा है दैट डज नॉट कंसर्न यू. वॉट एवर क्रॉसिंग द बाउंड्री ऑफ द सिस्टम, दैट इज माई मेन कंसर्न. ये आपको और समझ में आएगा when we'll study about the thermodynamic work. Okay, so now we have defined the thermodynamic system. Then next is, अब आपने जैसे ही सिस्टम डिफाइन किया, then comes कि सिस्टम को डिस्क्राइब कैसे करेंगे. ठीक है, आपने डिफाइन तो कर दिया, लेकिन हाउ यू विल डिफाइन और डिस्क्राइब द सिस्टम. ओके, सो हाउ टू डिस्क्राइब द सिस्टम. Okay, so there are basically, we describe the system with the help of properties. Okay, with the help of basic properties we describe our system, and we mainly deal with the macroscopic approach for defining the system for macroscopic properties. For example, pressure, volume, temperature, mass, number of moles, etc. These are the different properties which are used to define the system. आपको कैसे सिस्टम को डिस्क्राइब करना है, these are the properties which describe the system. Okay, so if I want to say what do you mean by a thermodynamic property or a property, you can say the characteristic that helps to describe the system is called property of the system. Okay, the characteristic of the system which helps to describe the system or describe the state of the system is called property of the system. Okay, I'm not writing this definition. Okay, then comes how can we describe. Okay, let me tell. First of all, there are two types of properties. First one you all know, intensive, and second one is extensive. Okay, extensive or extensive property means the properties which scales with the system size of the system, scales with the size of the system. Okay, जैसे जैसे सिस्टम का साइज इंक्रीज होगा, that will these property will increase, or we can, in other words, we can say dependent on the mass of the system. Okay, intensive property remains constant independent of the size of the system. Whatever is the size, the intensive properties will remain same, or in other words you can say independent of mass. Okay, for example, temperature, pressure, okay, density, conductivity. These are the different example for the intensive property. On the other hand, when we talk about extensive property, it is volume, total internal energy, total enthalpy. Okay, these are the examples of extensive property, and we all know that Extensive property per unit mass is an intensive property. For example, if I am saying the volume per unit mass, which is represented by specific volume, the specific volume is an intensive property. Okay. Similarly, internal energy per unit mass, it is represented by specific internal energy. This will be an intensive property. Okay. Then next comes how to define the state. सिस्टम की स्टेट को डिफाइन करें कैसे? So there are mainly two methods. First one is isolating the system with respect to surrounding. Second one is bringing the system to dead state. Okay, what do you mean by these two methods or these two statements? First one is isolating the system with respect to surrounding. Why we need to do that? Isolate. Why we need to isolate the system with respect to surrounding? For defining the state of the system. Okay. For example, I will take the same example जो अभी हमने discuss किया. This PVR. If I am saying at a particular time there is a continuous interaction between system and surrounding. Continuously कुछ लोग आ रहे हैं, continuously कुछ लोग बाहर जा रहे हैं. Now the entry and exit is not constant. Means दो जितने अंदर आ रहे हैं उतने ही बाहर जा रहे हैं. ऐसा कुछ कोई कंडीशन रिस्ट्रिक्शन नहीं है. ओके. दो तीन पांच लोग अंदर आए, तीन लोग बाहर चले गए. देन अगेन दो लोग अंदर आए, पांच लोग बाहर चले गए. So there is no restriction how many persons are coming inside that PVR and how many persons are leaving the PVR. Okay. So at any time, if I want to ask you to tell me what is the number of persons which are inside the PVR. Okay. किसी टाइम पे मैंने आपसे पूछा कि कितने लोग इस पीवीआर के अंदर बैठे हुए हैं एट दैट पर्टिकुलर इंस्टेंट. ओके. व्हाट यू कैन नॉट टेल. व्हाई? बिकॉज जैसे ही आप इधर से अगर काउंट करना स्टार्ट करेंगे, इफ यू वांट टू काउंट द नंबर ऑफ पीपल, आप जैसे जैसे काउंट करना स्टार्ट करोगे यहाँ से कंटिन्यूसली कुछ पर्सन अंदर आ रहे हैं, कुछ लोग अंदर आ रहे हैं और कंटिन्यूसली यहाँ से कुछ लोग बाहर चले जा रहे हैं. तो मे बी जिसको आपने काउंट किया वो बाहर चला गया और कुछ और लोग यहाँ पर अंदर आ गए. सो एनी टाइम यू कैन नॉट टेल कि दिस नंबर ऑफ पर्संस आर इनसाइड दिस सिस्टम. आ रहा है समझ में? ओके. किसी भी टाइम पे आप ये फिक्स नहीं कर सकते बिकॉज कंटिन्यूसली जो भी मास है, जो नंबर ऑफ पीपल्स है इनसाइड दैट सिस्टम इज वेरिंग विद रिस्पेक्ट टू टाइम. कंटिन्यूसली वेरी कर रहे हैं, आप उसको किसी एक पर्टिकुलर टाइम पे डिफाइन नहीं कर सकते. ठीक है. तो आप क्या बोलेंगे, सर आई कैन नॉट डिफाइन. मैं कैसे काउंट करूं? कंटिन्यूसली कोई आ जा रहा है, फिर कोई निकल जा रहा है, फिर कोई आ जा रहा है, कोई निकल जा रहा है. हाउ कैन आई डिफाइन? ओके. तब मैं क्या बोलूं कि लेटेस्ट से कि ऐसा करो, इस डोर को जो आपने एंट्रेंस लगा रखा है उसको भी क्लोज कर दो और एग्जिट को भी क्लोज कर दो. ओके. व्हाट आई टोल्ड कि आप एंट्रेंस वाले डोर को भी क्लोज कर दो और एग्जिट वाले डोर को भी क्लोज कर दो. अब क्या हुआ? ना तो कोई नया पर्सन अंदर आ सकता है, ना ही कोई अंदर से बाहर जा सकता है. एंट्रेंस इज क्लोज, एग्जिट इज क्लोज. ओके. तो जितने भी नंबर ऑफ पर्संस इस हॉल में अब होंगे वो क्या रहेंगे? कांस्टेंट रहेंगे. वो टाइम के साथ चेंज नहीं होंगे. ओके. सो मैंने किया क्या? द मोमेंट आई क्लोज द डोर आई एम आइसोलेटिंग माई दिस सिस्टम विद रिस्पेक्ट टू सराउंडिंग. आ रहा समझ में क्या बोल रहा हूं? आई एम आइसोलेटिंग द सिस्टम विद रिस्पेक्ट टू सराउंडिंग, द मोमेंट आई एम क्लोजिंग द डोर, मैं किसी को भी सिस्टम को मेरे सराउंडिंग से इंटरेक्ट होने नहीं दे रहा हूँ. आई एम नॉट लेटिंग माई सिस्टम टू इंटरेक्ट विद सराउंडिंग. इन दिस केस आई एम टॉकिंग अबाउट ओनली नंबर ऑफ द पर्सन्स. ओके, आप कहोगे कि सर एनर्जी इंटरेक्शन तो हो ही सकता है. राइट नाउ आई एम नॉट कंसिडरिंग एनर्जी इंटरेक्शन. मैं एक एग्जांपल ले रहा हूँ, आपको सिर्फ नंबर ऑफ पर्सन्स के एग्जांपल से आपको एक्सप्लेन कर रहा हूँ. ओके, सो आप जैसे ही आपने डोर बंद किया, आपने क्या किया, सिस्टम को आइसोलेट कर दिया. आइसोलेट का मीन्स ना तो सिस्टम में कोई मास इंटरेक्शन हो सकता है सराउंडिंग से, और ना ही कोई एनर्जी इंटरेक्शन हो सकता है. द मोमेंट यू आर स्टॉपिंग ऑल द इंटरेक्शन, जो भी सिस्टम में टेम्परेचर है वो टेम्परेचर मेंटेन रहेगा, जो भी प्रेशर है वो प्रेशर मेंटेन रहेगा. whatever characteristics of the systems are there, it will maintain. Then you can easily define all the characteristics. Okay, so that's why I am saying that isolating system with respect to surrounding is the first way of defining the state of the system. Okay, जैसे ही आपने आइसोलेट किया, प्रॉपर्टीज चेंज नहीं होंगी विद रिस्पेक्ट टू टाइम. आइसोलेट देखो, प्रॉपर्टी में तभी चेंज कर सकता हूँ, सॉरी तभी डिफाइन कर सकता हूँ जब फॉर अ फ्रैक्शन ऑफ टाइम एटलीस्ट वो प्रॉपर्टी कांस्टेंट रहे थ्रू आउट द सिस्टम. ओके, अगर वो कांस्टेंट नहीं है देन आई कैन नॉट डिफाइन. और उसको कांस्टेंट करने के लिए मुझे पहला जो तरीका है वो ये है कि मैं सिस्टम को आइसोलेट कर दूं. फॉर एग्जाम्पल, जैसे ही आप कॉफी को कप में रखते हो, ओके, आप कॉफी को कप में रखते हो, अगर आपने ऐसी कप में रख के सराउंडिंग में छोड़ दिया तो कंटिन्यूसली इसका टेम्परेचर क्या होता जाएगा, चेंज होता जाएगा. ओके, तो एक पर्टिकुलर टाइम पे आप जैसे टेम्परेचर मेजर करोगे ये कि सर ये टेम्परेचर, तब तक टेम्परेचर फिर चेंज हो जाएगा. फिर दूसरा बोला आपने, तब तक फिर चेंज हो जाएगा. कंटिन्यूसली टेम्परेचर वेरी करता रहेगा. तो आप ये डिफाइन नहीं कर सकते कि सर हाँ पूरे सिस्टम का टेम्परेचर ये है. यू कैन नॉट डिफाइन. अब आपको डिफाइन करना है टेम्परेचर पूरे सिस्टम का, तो आप क्या करोगे, इस कॉफी को उठा के एक थर्मोस में रख दोगे. आपने कॉफी ली, कॉफी को थर्मोस में पुट कर दिया. नाउ बिकॉज फ्रॉम दिस दैट थर्मोफ्लास्क और थर्मस देयर इज नो इंटरेक्शन, एनर्जी का इंटरेक्शन कोई नहीं है, एनर्जी ट्रांसफर नहीं हो रहा है. सिमिलरली देयर इज नो मास ट्रांसफर, मास का इंटरेक्शन नहीं है. तो आपने क्या करा, अगेन इस सिस्टम को आइसोलेट कर दिया. जैसे ही आपने आइसोलेट किया, व्हाट एवर टेम्परेचर इज देयर इट विल मेंटेन, इट विल रिमेन कांस्टेंट. सो नाउ यू कैन डिफाइन दैट टेम्परेचर. Okay, you can define that pressure. So that's why isolating system with respect to surrounding is one way. Another method is bringing the system to dead state. What do you mean by that? Dead state means zero potential, to change. ओके, मतलब क्या हुआ, जीरो पोटेंशियल का मतलब क्या हुआ, जब आपने इस एग्जांपल में, कॉफी वाले एग्जांपल में, तो कॉफी का मग आपने सराउंडिंग में रखा या सिस्टम के टेम्परेचर को सराउंडिंग के टेम्परेचर में रखा, बिल्कुल डेफिनेटली. ठीक है, जैसे ही आपने सिस्टम को, ये कॉफी का कप को रखा, लेट्स से यहाँ का कॉफी का टेम्परेचर 50 डिग्री सेल्सियस था और सराउंडिंग का टेम्परेचर 25 डिग्री सेल्सियस था. ठीक है, अब यहाँ से यहाँ हीट ट्रांसफर किया, कॉफी से, कॉफी का टेम्परेचर डिक्रीज क्यों हो रहा है, व्हाई द टेम्परेचर ऑफ कॉफी इज कंटिन्यूअसली चेंजिंग, बिकॉज द टेम्परेचर हियर इज 50 डिग्री सेल्सियस एंड टेम्परेचर हियर इज 25 डिग्री सेल्सियस. सो देयर इज अ पोटेंशियल which system has for the heat transfer. Okay, सिस्टम की हीट ट्रांसफर के लिए एक पोटेंशियल एग्जिस्ट कर रहा है. ओके, अगर ये पोटेंशियल आप इसको जीरो के इक्वल कर दोगे तो क्या होगा, कोई भी हीट ट्रांसफर नहीं होगा. जीरो का मतलब क्या हुआ, मैंने इस कॉफी को भी किस टेम्परेचर पर रख दिया, 25 डिग्री सेल्सियस पे ही रख दिया. ओके, अब यहाँ पर भी टेम्परेचर 25 है, सराउंडिंग का टेम्परेचर भी 25 है. सो देयर इज नो टेम्परेचर ग्रेडियंट और टेम्परेचर पोटेंशियल फॉर द हीट टू फ्लो. अगर हीट का फ्लो होगी, जब तक कोई टेम्परेचर डिफरेंस नहीं होगा तब तक हीट फ्लो नहीं होगी। ओके, सो मैं क्या कर रहा हूं, सिस्टम को सराउंडिंग और डेड स्टेट के इक्विलिब्रियम में ले आ रहा हूँ। डेड स्टेट का मतलब ही हुआ कि मैं सिस्टम को सराउंडिंग के इक्विलिब्रियम में ले आया, मतलब सिस्टम और सराउंडिंग के बीच में कोई भी पोटेंशियल नहीं बचा। ओके, सो व्हेन देयर इज नो पोटेंशियल बिटवीन सिस्टम एंड सराउंडिंग, सिस्टम की कोई भी प्रॉपर्टी चेंज नहीं होगी। ओके, तो प्रॉपर्टी चेंज नहीं होगी, देन आई कैन डिफाइन इजीली व्हाट आर द डिफरेंट properties of the system. Okay, so this is the way how to define the system. Another is what are the number of properties required to define system. Okay, कितनी प्रॉपर्टी मैं डिफाइन करूं कि मैं सिस्टम को इजीली डिफाइन कर पाऊं। ओके, देयर कैन बी नंबर ऑफ प्रॉपर्टीज जो सिस्टम को डिफाइन कर सकती हैं, लेकिन मिनिमम मुझे कितनी सारी डिफाइन करनी है, whether I have to define all the properties or I have to define some definite properties, की इतनी प्रॉपर्टी डिफाइन कर दी, अब fully defined हो गया सिस्टम। So what are the number of properties which I have to define? Okay, so that comes, for example, if I am talking about in this class, whatever, let us say कि right now 54 students are there. Okay, now if I want to define any individual student, okay, अगर किसी में इंडिविजुअल स्टूडेंट को डिफाइन करना चाहूँ इस 54 स्टूडेंट्स में से, तो मैं क्या कर सकता हूँ, आई कैन कॉल हिज फर्स्ट नेम। ओके, मैं उसका फर्स्ट नेम बोल सकता हूँ, बट मे बी चांसेस आर देयर कि एक ही फर्स्ट नेम के दो लोग हों वहां पे, या मोर देन 2 लोग पर्सन क्लास में हो, दैट मे बी द चांसेस। सो डिफाइनिंग द फर्स्ट नेम ओनली विल नॉट फुलफिल माई कंडीशन। मैं किस बंदे को बुलाना चाह रहा हूँ, किस स्टूडेंट्स को रेफर करना चाह रहा हूँ, आई कैन नॉट डिफाइन दैट। सो व्हाट आई विल डू, आई विल ऐड द लास्ट नेम। ओके, अब लास्ट नेम भी डिफाइन करना होगा। ओके, सो दिस विल अगेन इंक्रीज द हाउ दैट पर्टिकुलर पर्सन, कि मैं उस पर्टिकुलर पर्सन को डिफाइन कर पाऊं, पर्टिकुलर स्टूडेंट को। ठीक है, अब मे बी द कंडीशन इज दैट सेम नाम और सेम लास्ट नेम के भी स्टूडेंट्स होते हैं। मे बी अमित कुमार, लेट अस से वी हैव अ नेम, फर्स्ट नेम इज अमित and last name is Kumar. With this name Amit, there can be number of students in this class, and Kumar also with last name, there can be number of students. So अगर मैं दोनों चीजें बोल भी रहा हूँ, अमित कुमार भी बोल रहा हूँ, तब भी मैं एक क्लियरली मैं डिफाइन नहीं कर पा रहा हूँ कि किस अमित की बात कर रहा हूँ, किस अमित कुमार की बात कर रहा हूँ। ओके, देन आई कैन ऐड another thing, maybe name of the college or roll number or something, so that मैं ये कंटिन्यूसली प्रॉपर्टीज ऐड करता जाऊंगा जब तक कि मैं एक पर्टिकुलर स्टूडेंट को यहाँ में डिफाइन ना कर पाऊँ, इंडिविजुअल स्टूडेंट को मैं डिफाइन ना कर पाऊँ फुली, कि मैंने वो सारी प्रॉपर्टीज आपको बता दी, तो यू कैन डिफाइन यस ही इज टॉकिंग अबाउट दिस पर्सन। ओके, सो these are the minimum number of properties which required to define any system. Okay, जब मैं बात कर रहा हूं कि क्या है number of properties to required to define the system, then the minimum number of properties which can easily define the system, minimum number of things, first names, last name, college name, roll number, these things अगर मैं ये चारों चीजें डिफाइन कर दे रहा हूं, then अगर मैंने ये चारों चीजें किसी भी स्टूडेंट्स के लिए डिफाइन कर दी, आई कैन डायरेक्टली से कि इस स्टूडेंट्स के बारे में बात कर रहा हूं मैं, या कोई और भी इजिली पॉइंट आउट कर सकता है कि इस स्टूडेंट के बारे में बात चल रही है. ओके, so that is the meaning of defining or the number of properties required to define the system. Okay, and that properties comes for single component homogeneous. For single component homogeneous system, the minimum number of properties required, minimum number of independent properties required are n plus 2. N, there is no variable, n is number of moles. Okay, plus any two another properties of the system. Okay, सेंटेंस को समझ लेना ध्यान से. n प्लस 2 का मतलब ये नहीं है कि n अगर मेरे नंबर ऑफ मोल्स मेरे पे 5 है सिस्टम में तो 5 प्लस 2 7. नो. ओके, 5 प्लस 2 7 प्रॉपर्टीज नहीं चाहिए. n प्लस 2 का मतलब है कि आई शुड बी नोइंग नंबर ऑफ मोल्स and any two property. If I know these two things, then I can fully define a single component homogeneous system. Okay, yeah, this number 2, it comes from the Gibbs phase rule. Okay, so for any single component homogeneous system, we need number of moles, whatever the number of moles inside the system, and any two independent intrinsic properties. If I am able, I have these information, then I can define the system easily. All other properties become dependent on these three things. Okay, for example, if you are talking about an ideal gas, we know that ideal gas equation is PV is equal to nRT. You know the number of moles. This you know. Up, after number of moles, if you have any two properties, let us say pressure and temperature, you have pressure and you have temperature, then you can easily define what is the volume. You can easily find out what is the volume because R is constant. This is universal gas constant. Okay, and when you find out volume, all other properties, internal energy, entropy, enthalpy, total energy, will become dependent on these properties. Okay, now let me tell you what do you mean by homogeneous and heterogeneous system. Okay, homogeneous. Homogeneous system means if the system is chemical and physical, the properties, chemical and physical properties are same throughout. What does that mean? मतलब सिस्टम की केमिकल प्रॉपर्टीज वॉट एवर केमिकल कंस्टिट्यूएंट्स आर देयर एंड फिजिकल प्रॉपर्टीज वॉट एवर डिफरेंट फेजेस आर देयर, अगर वो सेम है थ्रू आउट दिस सिस्टम, then I will say that this is an homogeneous system. For example, if I am talking about coffee, okay, coffee is an example of homogeneous system because the chemical composition थ्रू आउट द कॉफी क्या है, सेम है. फिजिकल कंपोजिशन मीन्स द फेज इन विच ऑल द कंपोनेंट आर एग्जिस्टिंग. तो सभी फेज, जो सभी कंपोनेंट है वो किस फेज में है, लिक्विड फेज में एग्जिस्ट कर रहे हैं. ओके, सो द फेज थ्रू आउट द सिस्टम इज सेम, द केमिकल properties throughout the system is same. That's why this system is homogeneous system. Okay. On the other hand, opposite to homogeneous is heterogeneous system. The example of heterogeneous system is water with ice cube. Best example of the homogeneous system is water with ice cubes. और why? देखो, chemical composition is same. Water, whether it is in liquid phase or it is in solid phase, chemical composition will be same, but the physical properties of liquid water and solid water will be different. Okay, that's why this is an example of heterogeneous system. Homogeneous system, the chemical and physical both properties should be the same. मतलब chemically और physically दोनों properties concurrently सेम होनी चाहिए. ऐसा नहीं कि सिर्फ chemical composition सेम हो और सिर्फ physical composition सेम हो. Concurrently both properties should be same throughout the system. Then it is only we can say it is an homogeneous system. Otherwise we cannot. Okay. So on the basis of that, and component, if you want to talk about component, then whether it is a single component system or a multi component system. If we are talking about coffee, then it is a multi component system. Why? Because coffee बनाने के लिए आपको क्या चाहिए, डिफरेंट डिफरेंट इंग्रेडिएंट्स चाहिए, उनका कंपोनेंट क्या है, अलग अलग. ठीक है. On the other hand, if you are talking about this system, this is single component system. Why single component? Because water in liquid phase is also H2O, water in solid phase is also H2O. कंपोनेंट क्या है, H2O है दोनों फेज में, बट जो फिजिकल प्रॉपर्टीज है वो डिफरेंट है. दैट्स व्हाई इट इज हेट्रोजीनियस सिस्टम बट सिंगल कंपोनेंट. ऑन द अदर हैंड, कॉफी इज मल्टी कंपोनेंट सिस्टम बट होमोजेनियस सिस्टम. ओके. नाउ विद द आफ्टर दिस वी कैन डिफाइन गिब्स फेज रूल, through which, with the help of which we define what are the minimum number of properties required. This is the Gibbs phase rule. Okay. So as according to the Gibbs phase rule, number of phases plus F is equal to C plus 2, where P is number of phases, F is number of independent properties required to define system, and C is, you also can say, the degree of freedom. Okay, and C is number of chemical component. Okay, फॉर एग्जाम्पल अभी जो हम लोगों ने देखा कि फॉर होमोजीनियस सिंगल कंपोनेंट सिस्टम n प्लस टू, जो टू प्रॉपर्टीज चाहिए मुझे इंडिपेंडेंट, वो कहां से आ रहा है. लेट अस से फॉर फर्स्ट एग्जांपल, सिंगल कंपोनेंट single phase. Okay, system. So when we are talking about single component, single phase, that means P is equal to 1 and C is equal to also 1. Single phase, single component. So P 1 plus F is equal to C 1 plus 2. So 1 so when cancel, F will be 2. This is the same 2 that we wrote in previous slide. This one. Okay, N plus 2. So for single component homogeneous system, the minimum number of properties required are number of moles and any other properties. Okay. Similarly, if we talk about second single component, two phase system, that means pressure is number of phase are 2. This clearly written two phase system. Number of components are 1. For example, again, just now we discussed mixture of water and water vapor. Water and water vapor. This is the example. और दूसरा भी अभी एग्जांपल देखा, वाटर एंड आइस क्यूब. Here 2 plus F is equal to 1 plus 2. So F will be 1. That means if we are having a single component in two phase system, अगर मेरे पास for example water and water vapor का mixture है, then I only need one individual property to define the system. Because जब आप बात करते हो टू फेज रीजन की, फॉर एग्जाम्पल अगर आपके पास वाटर और वाटर वेपर का मिक्सचर है, ठीक है, एंड आई एम सेइंग दैट प्रेशर इज P एटमॉस्फेरिक. ओके, एटमॉस्फेरिक प्रेशर है एंड वाटर वेपर मिक्सचर आर एग्जिस्टिंग, coexisting. Okay, what will be the temperature? You can easily tell that sir temperature will be around 99.9 degrees Celsius or 100 degrees Celsius. 100 degrees Celsius टेम्परेचर होगा और 99.9 डिग्री सेल्सियस टेम्परेचर होगा, दैट यू कैन इजीली टेल. व्हाई? बिकॉज एट दिस प्रेशर दिस टेम्परेचर इज फिक्स्ड. इस ही टेम्परेचर पर वाटर विल स्टार्ट कन्वर्टिंग इनटू वाटर वेपर, नॉट एनी अदर टेम्परेचर. दैट्स व्हाई वी नीड ओनली वन प्रॉपर्टी to define the system, because other properties are dependent on this property. Similarly, अगर मैंने टेम्परेचर बोल दिया कि 99.9 डिग्री सेल्सियस फॉर वाटर वेपर एंड वाटर मिक्सचर, व्हाट विल बी द प्रेशर? यू कैन इजीली से दैट सर प्रेशर विल बी P एटमॉस्फेरिक. व्हाई? बिकॉज यू नो कि इस टेम्परेचर पर इसी प्रेशर, जब P एटमॉस्फेरिक प्रेशर होगा तभी वाटर वेपर में कन्वर्ट होगा, अदरवाइज नहीं होगा. Okay, then next is single component three phase system. Okay, then single component three phase means P is equal to 3, C is equal to 1, so F will be 0. What does that mean? F0 means you don't need any property to define the system. Why is that? We don't need any property to define the system. That is why, because this point where all the three phases are coexisting is a unique point, unique state. Okay, and that state is called triple point. You will study when we'll go through the properties of pure substance, not critical point, it's triple point. Okay, so it is a unique state. At that point only we can have all the three phases of the system coexisting at the same time. Okay, for example, if I am talking about water, then at temperature 0.01 degrees Celsius only the triple point of water will exist. So मुझे बोलने की जरूरत नहीं है कि what will be the temperature. If I am saying the triple point of water, then temperature is already fixed. It will be 0.01 degrees Celsius. On the earth, if I am saying that triple point of water, then pressure is already fixed, 0.61 kilopascal. Okay, so these properties are already fixed. The moment I am saying the triple point properties of water, these properties are already fixed. Okay, so that's why you don't need any property to define the system. Okay, then comes after that important points with respect to properties. With respect to properties. Okay, first one, we all know that properties are point function. Now, what do you mean by point function? Point function means it depends only initial and final conditions. Does not depend on how that process has been done. For example, अगर मैं if I am drawing a PV diagram, pressure and volume. Okay, and let us say initial state was this. System was initially at this pressure, at this volume, and final pressure and volume is this. Okay, अब for going from this state 1 to state 2, there can be number of ways. For example, system can have a constant volume process, then a constant pressure process. This is one way. On the other hand, system can first have constant pressure process and then constant volume process, or system can have a process in which both the pressure is reducing and volume is increasing. Okay, so this is one path A, this is another path B, this is another path C. Okay, so all these paths are different. Path A, path B, path C are different, but the change in volume between this and this point is independent of any path. If I will say what is the change in volume from state 1 to 2, you will say, sir, it is V2 minus V1. Whatever is the path followed for by the system, it does not have any effect on this property value. Okay, that's why we are saying that these are the properties are point function. Let me give you another example. Let us say there is a building. You have a building. Okay, let us say it is 3-story or 4-story building. Now you have a bucket of water at ground. Okay, you have a bucket of water at ground. You want to raise this bucket of water to the top of this building. Okay, let the height of this building is h. So there are two ways. There can be number of ways, but basically when I am talking, there can be two ways. First is I will just tie a rope and I will stand here and I will pull this bucket from here directly and I will put it here. Okay, with the help of rope I can directly pull it to the top of the building or roof of the building. On the other hand, there can be another way that if I don't have that rope, I have to follow the stairs. I have to follow all the stairs and then I will reach the top of the building. Okay, but I followed two paths. First was directly pulling it through the rope. Second was passing through the stairs. But when I am talking, what is the difference or what is the change in potential energy of the water in the bucket? What you will say? You will say that change in potential energy is mass in the bucket into G into H. In both cases, the change in potential energy will be the same, whether you are going through the stairs or whether you are going through pulling it through the rope. Okay, so it is not depending on the path followed. That's why I have written properties are point function. Okay, second is properties are independent of past history. What does that mean? If we threw it, I'm not getting what you are trying to say. Okay, the properties are independent of past history. What do you mean by past history? That means किस path को follow किया, एक बार आप यहाँ पहुँच गए, then whatever path you followed, that doesn't have any concern. That's why it is independent of path history. Sorry, past history. Okay. Third is properties are exact differential. Okay. What do you mean by exact differential? Exact differential means you can write the change in property or integral directly. If it is a property, then you can write it as v2 minus v1. Okay, and if this is not a property, you can write, for example, if I am talking about work 1 to 2, I cannot write w2 minus w1. What is the difference between exact and inexact differential? That you will learn in mathematics, or you can search on my channel also. I have one lecture on this. Okay, so properties are inexact differentials. Okay, then state of the system we have already defined. What do you mean by state of the system? I will not write the definition. State is any condition of the system which can be defined with the help of properties, that is called state of the system. And change in state of the system. Okay, for example, this is pressure, this is volume. Okay, I defined just now, I did it. This is the first and this is second. This is the state of the system. Why this is state of the system? Because it has been defined with some properties. This is the value of pressure at this state. This is the value of volume at this state. Similarly, state 1 has been defined with the help of some properties. Okay, so that's why it is called state of the system. Okay, and if there is any change in state of the system, for example, if the system is changing its state, then this is called process. Okay, change in state of the system is called process. And series of states अब during this process, अब देखो when I have to define this process, how can I define? अगर दो पॉइंट्स हैं मेरे पास 1 और 2 और आई एम सेइंग दैट 1 से 2 सिस्टम को जाना है, अब सिस्टम ने ये पाथ फॉलो किया है, हाउ कैन आई बी श्योर? until or unless I don't know the intermediate points. अगर मुझे intermediate points नहीं पता है इसके बीच के intermediate states के, then I cannot define that this path has been followed by the system. Okay, are you getting my point? मैंने बोला कि अगर सिस्टम 1 है, सॉरी स्टेट 1 एंड स्टेट 2, आई एम सेइंग दैट सिस्टम इज मूविंग फ्रॉम स्टेट 1 to स्टेट 2, but I have to define the path which system has followed. Okay, then for defining the path I have to be knowing the intermediate points of the system. Okay, until or unless I don't know the intermediate points of the system, I cannot define a process path. Okay, so this is called process path. Up, what is the need of defining a process path? Non-quasi static, you don't have the intermediate points. Okay, we will discuss this. We will discuss what is the quasi static and non-quasi static. Okay, so we what is the need? Why I am focusing to find out what is the process path? Okay, process path क्या है मेरा, ये मुझे find out करने के लिए इतना क्यों eager हूँ? Why I am so much eager to find out प्रोसेस पाथ, नहीं जरूरत क्या है इसकी? ओके, सो प्रोसेस पाथ फाइंड आउट करने का मेन पर्पज इज, इफ आई नो द पाथ आई कैन टेल व्हाट इज हाउ मच अमाउंट ऑफ एनर्जी वी आर वेस्टिंग और हाउ मच मोर अमाउंट ऑफ एनर्जी वी कैन यूटिलाइज. ओके, सो बाय डिफाइनिंग पाथ I can tell how much energy we are wasting. For example, अगर आप पॉइंट ए से पॉइंट बी की तरफ जाना है, मैंने आपसे बोला कि लेट अस से कि मुजफ्फरपुर टू दरभंगा जाना है, सॉरी दरभंगा कह रहा हूँ, लखनऊ. ओके, if you want to, I am saying that we have to travel from Muzaffarpur to Lucknow. Okay, so there are more than one ways, मतलब एक से ज्यादा तरीके हैं मुजफ्फरपुर टू लखनऊ जाने के. Okay, but there can be, let us say this way, this is another way by going through the Patna, there is another way by going through the that Motihari or Gopalganj. Okay, so there are different routes which I can follow for moving from Muzaffarpur to Patna, sorry Lucknow. Okay, I am just taking an example. But if I don't know which route you have followed, I cannot tell what will be your petrol consumption. I cannot tell you how much time will you take. I cannot tell you how many times you have to take rest, because I don't know the path which you are following. I just told you that go from Muzaffarpur to Lucknow. Okay, the moment I know the path, you say, sir, I am following this path. Okay, then I know that you are following this path. Okay, so what is the length of this path? How much time it will take? How many stoppages you have to take? Okay, so by defining the path, I am easily able to extract the different all other properties. Okay, On the other hand, if you are saying that I am following the another part through Patna, then I will say why you are wasting your energy. You should follow a direct path. Why you are going from one place to another place, roaming whole around? Okay, why you are wasting your petrol by roaming here and there? Just follow a straight route. So by knowing the path, I can tell you that how much energy you have wasted, how much petrol you have wasted while moving here and there. Okay, so that is the reason we focus to define the process path. Okay, until or unless we are not able to define a process path, we will not able to analyze different properties or different interaction between system and surrounding. Okay, any doubt? Okay, so for defining the process path, we define a process that is called quasi static. Quasi static process. Okay, so what do you mean by quasi static process? Quasi static process is, quasi means almost, and static means without motion. Okay, so without mean quasi static means a process which is almost stationary. For example, if I am saying this is pressure and volume, and this is one piston and cylinder arrangement. If I am saying that initially pressure and volume was this one condition, almost close to equilibrium, yes, very slow, yeah. Okay, how it can be very slow? Let us say कि I have a piston, I have a cylinder. Inside this piston cylinder, some gas is filled. And I have a weight W which I have put on this piston. मैंने एक W weight piston के ऊपर पुट कर दिया, रख दिया, ठीक है. अब जैसे ही मैं वेट को इस वेट को हटाऊंगा यहाँ से, तो क्या होगा? सिस्टम फटाक से विद इन नो टाइम सिस्टम विल चेंज इट्स स्टेट एंड इट विल कम इनटू अनदर इक्विलिब्रियम स्टेट. होगा? लेट अस से द सेकंड इक्विलिब्रियम स्टेट इज 2. ओके, सो जैसे ही मैंने पूरा वेट हटाया, सडनली पिस्टन फटाक से मूव करेगा ऊपर और दूसरी स्टेट में जाके इक्विलिब्रियम में रुक जाएगा. ठीक है, सो नाउ यू नो द सेकंड पॉइंट. ऑब्वियसली ऊपर मूव करा है, प्रेशर विल बी लेस एंड वॉल्यूम विल इंक्रीज. ओके, नाउ द सेम प्रोसेस आई एम डूइंग अगेन. But this time इस टाइम मैंने क्या किया, इस वेट की जगह मैंने यहाँ पे रख दिए कुछ स्मॉल स्मॉल पेबल्स और स्टोन्स. ओके, अब मैंने इस पूरे टोटल वेट की जगह कुछ रख दी, कुछ स्मॉल स्मॉल स्टोन्स रख दिए. ठीक है, अब जैसे ही बेटा मैंने यहाँ से एक भी स्टोन, पहला एक सिंगल स्टोन हटाया, स्मॉल प्रेशर डिफरेंस क्रिएट हुआ. ठीक है, जैसे ही आपने एक छोटा स्मॉल पत्थर हटाया, स्टोन हटाया, जो नेट फोर्सेस हैं डाउनवर्ड, वो थोड़ा क्या हुआ, डिक्रीज हुआ. देखो इक्विलिब्रियम कंडीशन में कोई कब रहेगा, व्हेन द डाउनवर्ड्स एंड अपवर्ड फोर्सेस विल बी इक्वल, तब पिस्टन स्टैटिक कंडीशन में रहेगा, अदरवाइज नहीं रहेगा. ठीक, अब जैसे ही स्टैटिक कंडीशन में था, जैसे ही मैंने एक स्टोन यहाँ से हटाया तो ऑब्वियस सी बात है कि जो डाउनवर्ड फोर्स है वो फ्रैक्शन उसका अमाउंट चेंज हुआ। जैसे डाउनवर्ड फोर्स चेंज हुआ तो क्या होगा, पिस्टन विल मूव स्मॉल अपवर्ड डायरेक्शन एंड अगेन इट विल कम इनटू इक्विलिब्रियम, फिर से रुक जाएगा। ओके, लेट अस से एट दैट पॉइंट द प्रेशर इज समथिंग this and volume this. Again I removed another stone, then again piston will move slowly and will again come into equilibrium, so again another point I will have. Similarly, if I am removing slowly all the stones, I will get number of intermediate points in between state 1 and state 2. Okay, and through this intermediate points I can define a path. Okay, and this path or this process is called quasi static process. Why it is called quasi static process? Because almost यहाँ से लेके लेट अस से कि फाइनल स्टेट ये है जहाँ पे जब आपने सारे स्टोन्स रिमूव कर दिए। ओके, so from here to here एवरी मोमेंट सिस्टम क्या है, इक्विलिब्रियम में ही एग्जिस्ट कर रहा है। आप स्मॉल फ्रैक्शन, आपने स्मॉल स्टोन हटाया, प्रेशर में कोई वास्ट चेंज नहीं आया तो सिस्टम फिर से थोड़ा सा मूव करके फिर से इक्विलिब्रियम स्टेट में आ गया। तो स्टेट 1 से स्टेट 2 तक सिस्टम हैज पास्ड थ्रू नंबर ऑफ इक्विलिब्रियम स्टेट्स। ओके, that is the reason I can join all these equilibrium states and I can define a process path. On the other hand, अगर आप ये वाली प्रोसेस जो ये दिस नॉन क्वासी स्टैटिक, ओके, हियर यू नो ओनली इनिशियल कंडीशन एंड फाइनल कंडीशन। आपके पास इनिशियल कंडीशन की प्रॉपर्टीज थी, फाइनल कंडीशन की प्रॉपर्टीज थी, बीच में कहाँ पिस्टन पे क्या प्रेशर था, क्या वॉल्यूम था, इंटरमीडिएट पॉइंट्स पे यू डोंट नो। So if you don't know the intermediate points, you cannot define the process path. Okay, are you getting my point? Quasi-static process that's we define because we want to find out the process path. Process path find out करना क्यों जरूरी है, अभी हमने डिस्कस किया। So for getting what is the process path, we define a process that is called quasi-static process. Because for all non-quasi-static process or practical process, we cannot have the intermediate points की properties की value we cannot define। अगर intermediate points आपको नहीं पता है, मैंने आपको सिंपल एग्जांपल है बेटा, यहाँ से मैंने बोल दिया इस पॉइंट को, पॉइंट ए को पॉइंट बी से ज्वाइन करो, ये मैंने आपको बोल दिया। आप बोलोगे सर कैसे ज्वाइन कर दें? ओके, जब मैं बोल रहा हूँ कि आई एम नॉट सेइंग दैट स्ट्रेट लाइन से ज्वाइन करो, इफ यू आर सेइंग दैट सर स्ट्रेट लाइन से ज्वाइन कर दें, देन दैट विल बी ओनली वन केस। ऑन द अदर हैंड, अगर मैं आपको सिर्फ ज्वाइन करने के लिए बोल रहा हूँ तो देयर कैन बी इनफाइनाइट नंबर ऑफ वेज थ्रू विच यू कैन ज्वाइन पॉइंट ए पॉइंट बी। ओके, सो until or unless you don't have intermediate points, then you cannot join point A and point B. ठीक है, so that is the main purpose of defining a quasi-static process. Okay, so all the non-quasi-static process, for non-quasi-static process we don't define it by continuous line, we define it by dashed lines, keep that in mind. On the other hand, quasi-static process को हम continuous line के through denote करते हैं। Okay, so this is your non-quasi-static. Why? Because intermediate point मुझे पता नहीं है, I am not sure that this is the path system has followed, that's why मैं dashed line से represent कर रहा हूँ। On the other hand, quasi-static process I am sure that system has followed this path, तो quasi-static process को continuous line से show करेंगे। Okay, reversible process, frictionless quasi-static is known as reversible process. When you are talking about frictionless process, that is a meaning of quasi-static process। अगर आप प्रोसेस को इतना स्लोली कर रहे हैं, that is a frictionless process. Okay, so reversible is somewhat different. You cannot say that frictionless quasi-static is reversible process. Okay, quasi static process plus zero external irreversibility is called reversible process. Okay, when you are saying that process is quasi static, you are assuming that process or internal friction of the system is zero. Okay, because friction zero क्यों है? Because we are doing the process very slowly, so friction जो work कर रहा है that is almost zero. Okay, so for quasi static process the internal friction of the system is zero. Reversible और quasi static process is different process. Okay, वो हम लोग डिस्कस करेंगे, तो अभी से कूदो मत रिवर्सिबल पे. रिवर्सिबल जो प्रोसेस है वो धीरे धीरे समझ में आएगा आपको. ठीक है, सो I think that's it for today's lecture. 9:30 is there. I have another class, regular class. Okay. So we'll get. I hope you all have joined the Telegram channel tonight. Okay. मैंने आपको सबको मेल के थ्रू लिंक भेजा है टेलीग्राम चैनल का. मैं ग्रुप का लिंक इस क्या कहते हैं चैट में भी शेयर कर दूंगा. ठीक है, आप लोग अभी जैसे ही अब यूट्यूब पे अपलोड होगी मैं उसमें ग्रुप का लिंक शेयर कर दूंगा. ठीक है, उसमें उसके थ्रू आप ज्वाइन कर लें, बेटर रहेगा, क्योंकि मैं जो भी शेयर करूंगा वो ग्रुप के थ्रू शेयर करना इजी रहेगा. I will share the link in the comment section. Okay, and tell me one thing, whether you people need this PDF or not. Whatever we have discussed today, if you need, I will share the PDF in the Telegram channel, or I will leave it. Okay. Okay. Thank you, class. We'll meet on day after tomorrow.